Good evening, everyone. Beautiful evening to you. How you doing? How was today? Hope you guys are feeling great. How you guys doing? What's up? And how did you find the test this morning? How was it? Do you enjoy it? Oh, okay. Somebody said so easy. So this you'll be having round two tomorrow, the same time and the same venue. Let's see how you fare with those ones. Let's see how you fare with those ones. And some of the things we'll be teaching today, at least I know you'll be seeing at least a question on what we'll be doing today. All right. So what's the focus for today? Somebody said bring it on. All right, we'll see. So today's focus is basically very simple. All right. We have uh, we have a very we have vast amount of questions to solve. Uh, I'm sure by now many of you are very much familiar with permutation. You know, we have been focusing on permutation. Guys, I need to inform you. There are several kind of questions. You will see some I'm going to bring out today. The same basics you have been using is what you will use, but you have to be very smart. So let's get right into it. I don't want to waste any more time. And so I want to start from our last, the exercise I gave you before you left yesterday. And the exercise was this: find the number of ways you're going to solve lots of questions today. So please brace up that we can arrange the letters of the word HELL. So this is the word HELL. Now, don't forget, we're still trying to deal with permutation with conditions, which is probably one of the most examinable parts of permutation and combination, because people want to find out if you are able to tackle questions where you're giving certain conditions that must be met. Now, look at the first condition here. All right. This is the first condition. Good. So let's try and solve this, and let me see how. By the way, let me ask, since it was an assignment, what did you guys do yesterday? How did you find it? How did you find it yesterday? Okay, can I get some solution from you guys? This was the last example we dealt with yesterday. What's your solution, please? Can you quickly tell me something you did? Oh, anybody with an answer? Can I have an answer? Okay. The very first, what's question number A? What was the answer for question number A? Two hells will always be together. Do anybody have an answer? Two hells will always be together. All right. Let me try and help you right here. So look at the question. I told you yesterday that when you have okay, we have 12, somebody said 6, somebody said 6. Look at it. We have HELL. Now you're told that the two hells, which is what we have right here, they must always be together. That means these are some possible examples. You could have an arrangement that says LLHE, You could have an arrangement that says LLEH. You could have an arrangement that says HLLE. Do you get the whole point? So how many different possible arrangement can we have in which the LL must always be together? Now, this is how you are going to solve questions like this. You always solve questions like this using this idea that since the two L's must be together, you're going to take that two L's as one object. So these two L, we're not going to be seeing it as, normally, apart from having it being together, we would have seen it as 1, 2, 3, 4, four different objects, right? But because we are told now that the two L's must be together, you will take these two L's as just one object. So in that case now, we will no longer be having four objects, we'll be having three objects. So the way you can permutate this, arrange this in such a way that the two L's will always be together will be three objects, of course, three objects, and are you arranging the three of them, which is obviously 3 factorial. So that will be obviously 3 times 2 times 1. That will be 6 ways. All right. So that's going to be the answer for question number A. So let's try and solve question number B. All right. What will be question number B? We're told now that two L's will always be apart. Now, the first condition was like, make sure these two L's are together. Now, the second condition said, these two L's, they must be apart. That means we do not want any of this situation to exist. Now, there's something I'm going to do for you. I'm going to solve this in two different ways. Let me start from one that probably you can easily relate to. Now that we said the two L's will be apart, I want you to understand that if you don't have any condition at all, that means if you just said, how many ways can you permutate the word HELL? Now, if you don't have any condition at all, you're going to see situations where the L's were going to be together and situations where the L's are not together. Those are the two options you can have. That means if you just went on to permutate HELL without any condition, what you'll be having is that you would have situations where L will be together, LL will be together, and you also have situations where L are not together. So therefore, if you want to try and solve question number B, what you could do is to go on to act like as if you don't have any condition at all. You were just trying to permutate the word HELL. So how will you normally, imagine I'll give you this question, how will you normally permutate HELL? Of course, this falls under what we call indistinguishable object. And in this case now, don't forget I explained it yesterday. You're going to solve this by looking at this as four different objects. That will be four objects. You are arranging four of them. That will be 4 factorial. But because of this indistinguishable object, you have to divide with 2 factorial. So this obviously will be 4 times 3 times 2 factorial. Of course, over 2 factorial. This will be 4 times 3. This will be 12. Now, this will be in case you were asked this question without any condition. That means you're just told, in how many ways can you arrange the letters of the word HELL? So obviously, that would have been 12 ways. All right. Now, for you to then go on to satisfy question number B, that told you that two L's will always be apart. What you could just do is to go on and say, all right, if two L's will always be apart, if I go on to deduct from these general ways, the general ways without any condition, if I deduct from these 12 ways, the number of ways where two L's will always be together, I will be getting the situations where two L's are apart. All right. So that in that case now, for you to get question number B, you will just say 12 ways minus, of course, the number of ways we got when two L's will be together was 6 ways. That will be 12 ways minus 6 ways. We will be left with 6 ways. All right. So the general answer for these two questions, A is 6 ways, B is 6 ways. Good. Now let me try and drill you a bit using another different technique. I don't know if I even want to do that because of time. Probably you just know it this way, but there is another way I could go on to explain it, and that would be using the whole more like understanding that okay, if we have LL being apart, that means these are going to be possibilities. HE, or we can have EH, obviously. So I'm sure you agree with me that the way, look at, if I want to ensure that two L's will always be apart, that means L could be here or L could be here. That means one L here, one L here. Or I cannot, that means this is one possibility. Also, we can have a situation where L was here and L was here. Then we can also have the third possibility where L was here and L was here. So look at that way. We know we have three different ways that we can set this L. Now, but this H and E obviously can also happen in two ways. And that's why we're going to write the answer as 2 factorial, because HE can happen EH. That's what this one represents. Then also, my spot, the spot that where I can put my L, LL can be here. That's one way. LL can be here. That means it could be HE. This is one possibility. This one I wrote here now was LH LE. This is the second possibility. Then the third possibility was when you had maybe when we had H L E L. That's this third one. So this is three different possibility of having the spot. That's three different possibility. Now, don't forget, for each of these spots, we can obviously swap the L's. That means this L can come here, this L can come here. I explained that one under indistinguishable object. That will be over 2. Now, for us to purify this also using indistinguishable object, we go on to divide by 2 factorial, which was the number of ways L happened. So in this case, this cancels this. We're left with 2 factorial times 3. This will be 6 ways. So you don't have to stick to this if you don't really get it, but this is a way of solving that using a more manual way. All right, good. Now let's move on to a very important question. Please take this question and start solving immediately. I will write it on the board, obviously, but please listen up and take it quickly, because I want us to solve lots and lots of questions today. Now look at the question. A police department in a small city. A police department in a small city consists of 10 officers. Note that this department, the police department, consists of 10 officers. If the department policy, now the department has a policy. If the department policy is to have 5 of the officers patrolling the streets, look at the policy of the department. They want 5 officers patrolling the streets, then 2 of the officers working full-time at the station. All right, 2 of the officers working full-time at the station, and 3 of the officers on reserve at the station. So that means we have 5 of the officers. Don't forget we said a police department is mostly consists of 10 officers. Now, if the department policy is to have 5 of the officers patrolling the street, 2 of them working full-time at the station, and 3 of them on reserve at the station. Now, this is the question. How many different divisions of the 10 officers into the 3 groups are possible? How many different divisions of the 10 officers into the 3 groups are possible? So we have a police department. Please keep solving and you tell me your answer quickly. In a small city, consists of 10 officers. All right. Now we said the department had a policy, and that policy was to have 5 of the officers patrolling the street. So out of that 10 officers, we have 5 of them patrolling the streets. And then 2 of the officers were working full time at the station. And 3 of the officers were on reserve at the station. And the question is, in how many different ways? How many different divisions of the 10 officers into the 3 groups are possible? Do I have an answer already? So this is the question I want you to tackle quickly. Whatever you're going to use, we have talked about this before. So you have the basics of what you're supposed to use for this already. What's the answer to this? Do I have an answer already? So we have a police department consisting of 10 officers. In the department, there was a policy that said 5 of the officers are supposed to be patrolling the street, 2 of the officers are supposed to work full time at station, and 3 of the officers are supposed to be on reserve. Now, how many different divisions of the 10 officers into the 3 groups are possible? I was thinking people should get this answer in like 30 seconds. Where is goodness? Where is praise? Is praise on this chat group? Yeah, it's a 30-second question. It's very cheap. It's not something that requires so much. You just need to understand what is going on already is quite very visible. You have 10 people. You have 10 people, the 10 objects. Now, among these 10 objects, it's like, imagine, look at it this way. Okay, if I say this next thing I want to say, you people will get the answer. Look at the way to look at this, and you will be able to get the answer. So I'm going to do something. So let's say these are 10. Let's assume these are the 10 officers, right? Let's say these are the 10 officers that exist. Now, they now said we have 5 of the officers patrolling the street. 5 of them were supposed to patrol the street. That means in that case now, the 5 of them are going to be seen as as a group, and then we have 3 of them, 3 of the officers. These ones are supposed to be on reserve at the station, and then the remaining 2 are supposed 2 of them are supposed to work full time, and then 3 of them are supposed to be on reserve. Now, looking at this now, how do you solve this? Very simple. That means these all have the same characteristics. It's more like you cannot distinguish between any of them here, because this group are supposed to have the same role. They are supposed to be patrolling the street. They are, in terms of this policy, they are indistinguishable. All of them are having a duty. These other 3, they are the one on reserve, and these other 2, they are the one working full time. So if you look at this and you want to make different divisions, that means the meaning of different divisions means it's possible that this officer F now was brought here. That's an arrangement already. The fact that officer A was in group 1, Now, but you decided that, okay, officer A, I want you to be on reserve instead of group one. F, go and stay in group one. That's one of the division that is possible. It's also possible for you to say, okay, officer, hi, you go here. Do you see how many that will be? Because obviously you can put each officer in different groups. They're asking you now, how many possible divisions are possible? Of course, you have to use your knowledge of, indistinguishable object, because what you want to do now is to ensure that you are not getting, these are the things you want to take out. Normally, you would have just said 10 factorial, but in this case now, you can't do that. So it will be 10 factorial over 5 factorial, 3 factorial, 2 factorial. That's how you're going to deal with this. Because in this case now, you are able to categorize the first group, the first division, and then you want to make sure that none of this is not the permutation of maybe D being here and E being, that was not going to be part of it, because everything here is seen as just one. So it's not going to be, so you are trimming all those possibilities of, we're not asking you to just arrange police officers differently. We're asking you to create different divisions. So if you go on to say officer A, B, C, D, E were the ones in division one, this first group, and you go on to say officer D, A, B, C, E is also staying, that's not a new arrangement. So you want to trim all those ones out by doing this. That's what you are going to do. That you are trimming all the possibility of having, like you say, B, A, C, D, E, and then no, you don't want that. That's not going to be a new division, because it's still the same officers in that division. So what you are concerned about is how many different divisions of the 10 officers into the 3 groups are possible. So you cannot count GFH as a new division other than FGH. FGH and GFH and HFG, they are all still the same division. It's still the same officers. So that's why you have to use this measure to trim that out, to ensure that all these possibilities where IJ, JI, if you say, oh, I have a new division, JI is there, JI is not going to be a different division than IJ. So to do all this, you have to solve it using your knowledge of indistinguishable object. And I'm sure at the end of this, you should get your answer to be 2520 ways. All right, good. Now, let's do something quickly. Let's do another question. Please take it down very quickly. It's going to be, let's see. I think at this point, I would love you to do this under like maybe 60 seconds. Now, 10 children are to be divided into an A team and a B team of 5 each. So we have 10 children, and they are supposed to be divided into 2 teams. Team 1 is called A team, and team 2 is called B team. And they said of 5 each. That means you are dividing each of these children 5 into team A and team B. All right. Now the question is, the team A will play in one league, and team B and the B team will play in another league. How many different divisions are possible? Notice the word again, divisions. This case now, we're not concerned about people or objects. We're talking about the divisions. So how many different divisions are possible? All right. 10 children are to be divided into an A team. 10 children are to be divided into a team that we have team A, an A team, and we have another team, we call it B team, and a B team of 5 each. That means each of these teams will have 5 children each. Now, the team A will play in a different league. The A team, let me call it A team. The A team will play in one league. And the B team, looks like somebody has gotten the answer, but in another. Now, notice the context of the question now, which is very vital. The context of the question said, how many different divisions are possible? That's the question. So again, look at it. In this case now, you're concerned about divisions. So we have two teams now. We have 10 children. Let's assume this were the 10 children. Let's assume we use the same alphabet. So we have A, B, C, D. Now, let's say this is team A and this is team B. Now, when they ask a question like this, you need to understand the context of the question. What's the context of the question? We divided these 10 children into two teams, A and B. Now, this A will play in one league, this one will play in another league. They're now asking how many different divisions are possible. Let me just give you context to that. If I have this is a division that is possible. But I could also have F come here and A come here. That means I can have a team where F was not in team B, F was in team A, and A was here. That's a division. That's another arrangement that is possible. I could also have J come here and A. Now, if I have J coming here and C coming here, that's another division. So that's exactly the context of the question. Divisions is what they're asking for here. That means how many different divisions can you have? So again, you have to use the idea of indistinguishable objects, where you have 10 objects, but now you are trying to divide them with there is like an identity with each of the team. That means once you have this division, you call them the A team. Once you have this division, you call it the B team. So all you want to be careful about now is that you do not want a situation where you are repeating the same division, where you are writing, for instance, maybe you are writing B, A, C, D, E, and you want to call this a different division. No, this would be wrong, because this is still the same A team. Because in this case, we are not concerned about arranging the people. No, we are concerned about the division. So this is still the same division. So you will not count this one as a new one. So we have to purge this one out of all these possibilities where you can reshuffle these five numbers. And the different possible ways of you reshuffling these five objects is 5 factorial ways. So you have to purge that out of your general arrangement. And the same thing goes here. You want to purge all the possibilities. Now, once you have purged that possibility out, the remnant will mark the different divisions. Because in that case now, what if you are able to swap maybe D here and H comes here? Once that happens, then you are fine. That's still a different thing. But you will just want to ensure you purge out all the repetitions that can happen from you maybe saying G, I, J, F, G. Sorry, G, I, J, F, H. And if somebody doesn't look carefully, they almost think this is a different arrangement. But it's still the same thing you are repeating. This is still the same former B team. So that's why you want to extract all these ones out. And the different ways you can deal with, you can have this scrambling happening is 5 factorial ways. Obviously, you know this is 5 objects here. So if the different ways you can scramble these 5 objects will be 5 arranging the 5 of them, which is 5 factorial. So you have to purge that possibility out. You are purging that out with this for this team A with this, and you're punching that out with this. Every other remnant, don't forget we are permutating the entire 10 object. So if you have punched these 2 possibilities that I just explained out, every other thing will give you the result of this. All right. So this is, what do you get as the answer here? I think some people said they got 252. How many of you got 252? Good. So I believe you have learned something very vital at this point. This is, you can see how by using a question came out. This question now is a question that it looks so maybe difficult or something, but all you needed to use was your knowledge of indistinguishable object, right? Good. Now, again, I told you already, and we have lots of questions. I want to throw lots of questions to you, and we also still want to talk about equation involving permutation. So let's take this next question down very quickly, please. I want to see you solve. Okay, you know what? Let's quickly do a little bit on equations involving permutation, and let's see how you fare with that. Then we'll still come back to these conditions. These conditions, they are something that I know lots of students sometimes have issues with, and that's why we want to tackle it extensively. So that now, look at this question, guys. Let me see who's going to get the answer without ticking. Look at this question. So we are under, by the way, just so you know, we are under equation involving permutation. Look at the question. The very first question we'll be dealing with. 12 permutation R is equals to 1320. You have to find R. Anybody with an idea there? Can I give you like 60 seconds to get this answer? Look at this question. You have 12 permutation R now, and you are told to find R. By the way, as I told you guys already, you'll be having another round of testing tomorrow. All right, and what we're dealing with right here in this class will also be significant in answering the questions you'll be seeing. All right, so ensure you pay real attention to what we're doing right here. So we have 12 permutation R equals to 1320. What is the value for R? What is the value for R? And quickly also, if you are yet to give us a thumbs up, please quickly do that. It's not going to take your time at all. Just give us a very great thumb up. Okay, now I've seen different answers here. 110, 110. Somebody says simple stuff. Okay, can I get the answer for the person that says simple stuff? And what is the answer? We have different answers coming. R is 10. Goodness said R is 10. Okay. Somebody said it's 110. So we have 110, 10, 3, 3, 3. Some people say 3. Okay. Now let's solve this together. Look at this. This is the reason why you have to have the right basics under permutation. All right. By the way, thank you for saying that. That person that said 110 is not possible. 110 is not possible. Goodness is trying to change his answer to R being 2. Somebody said it's 3 and 10. Okay. 3 and 10. How can 3 and 10 be correct? Okay. Now, let's see how it's going to go. Can you just let's pay attention for those of you that probably don't understand what's going on. Also, those of you that said R was 110, that's mathematically impossible, because how could you say 12 objects and you are arranging 110 of them? Does it really, do you understand? You have 12 objects. So if R was 110, if R was 10, maybe it's still feasible with R being 10. But how can you have 12 objects and you are arranging 110? Of course, that's not feasible. All right. You can only arrange, the highest number you can arrange when having 12 objects is 12. The lowest is 0. So you can arrange nothing or arrange everything, which will be 12. So this is 110 is not a possible answer there. All right. So let's see, how do you get the right answer? Let's see how this goes. Also, you need to remember your general formula for n permutation R being n factorial over n minus R factorial. If you don't know this, you will have a difficult time in solving this question. So let's try and apply that to what we have right here. We have 12 permutation R. That means we'll be having 12 factorial over 12 minus R factorial now is equals to 1320. That's just the very first that's the very first direction we can take for us to get our answer. So now, of course, one of the things I'm sure you understand in mathematics is when you have a problem like this, trying to move on from something like this, 12 minus r, since you don't know how, is not as easy as that. So one of the things you want to do is always collecting like terms. That means you want to bring the ones that have more like similar values, similar attributes, similar feature. You want to bring them close to each other, and you want to take the ones that don't have as much similar attributes to another side. So you can see this 12 factorial. If I press it on the calculator, I will get a final answer that is numeric. Now I have 1320 here also. This is numeric. But this 12 minus how, I don't have something I can do so much with it right now because it's not numeric. All right. So what I want to do is cross multiply. So I'm sure you understand how to cross multiply. Of course, there are other techniques you can use to achieve this, but the most basic one I'm sure many of you understand is having your cross multiplication. So we have 12 factorial equals to 1320 times 12 minus r factorial. So what I want to do now is to divide both sides by 1320, 1320. So obviously I have 12 factorial over 1320 equals to 12 minus r factorial. This is now a much more better argument to solve because now I've been able to bring the numeric values to one side and the one having an unknown value to the other side. All right, good. Now, a much more simple way of achieving this will be for me to just do something a bit tricky. And this is why you need to be very solid in knowing how to manipulate the right way. So if you go on to have, of course, I'm sure nobody here is disputing that 12 factorial is the same thing as 12 times 11 times 10 times 9 and so on and so forth. Let's just hang it here. All right. I'm sure nobody disputes this fact. Now, if you go on to press 12 times 11 times 10, if you go on to press this, of course, if you want to go on to press 12 factorial and divide by 1320, you are free to do that also. But of course, if you look at 12 times 11 times 10, it's going to give you 1320. So I can just decide to leave it like this and say 1320, and then this is just doing proper arithmetic. So one thing I can do right here is to cancel out all this because this is the same thing as this. So I'm left with 9 factorial. All right. So you can press your calculator perfectly if you know you don't like this movement. So look at what I have here. All right. So if you look at what I just did here, that means I have 9 factorial is equals to 12 minus. Let me write this much clearly. It's 9 factorial. 9 factorial is equals to 12 minus r factorial. Are you seeing this? Now look at what we have here. This is basically something I'm sure you can all relate to. We have something factorial. We are saying now, because this is the mathematical argument here, is we are saying 9 factorial was equals to this thing factorial. If 9 factorial is equals to this thing factorial, that means what this is must be the same thing as this. That's the rule of equality. If I say x is equals to y, or let me say it this way, if I say x is equals to z minus p, that means I'm saying z minus p is actually x. That's the meaning of equality. So if I said 9 factorial is 12 minus r factorial, that means 9 is basically equals to 12 minus r. That's the meaning of that. Since we said they were equal, that means 9 was equals to 12 minus r. So in this case now, you can see that your r will be equals to 12 minus 9, and our r will be equals to 3. That's the way it works. Can you see how beautiful this is? That's equation involving permutation, which is some of the things I'm very sure any examiner is willing to examine students on, because it's very, very examinable, and you need to prepare adequately for it. So can you try this next one? We're still on equation involving permutation. Seven permutation R equals to 840. This question number 2. 7 permutation R is equals to 840. Find R. You have to find a value for R. All right, so what's the answer? Anybody with an answer yet? Somebody said R was 4. Okay, can we get other answers? Some other people are saying R being 4. Somebody said 4 is R. Okay. Okay, so everybody's writing R being 4. That means it's very obvious, like it's very likely your R will be 4 because it looks like everybody are siding with the answer being 4. So of course, following the same direction we used, we have 7 permutation R. This obviously will be 7 factorial over 7 minus R factorial being equals to 840. Again, you want to cross multiply this to have 7 factorial equals to 840 multiplied by 7 minus R factorial. You want to divide through by 840 so that you can be able to have something much more feasible to solve. So we have 7 minus R factorial. Now, what do we have right here? 7 factorial over 840. We have that's 5040 over 840 equals to 7 minus R factorial. And what do we get from that? We get 6. So that means 6. Is it 6? Am I correct? Is that is it 6 or 3? What is 550? Are you sure? Sorry, let me type this on my calculator. Okay, 6. Okay, that's correct. So 6 equals to 7 minus R factorial. Now look at things right here. You have 6. We have this. This looks like almost like an anomaly because in this case we have 6. We don't have a factorial there, while in this case we have a factorial there. But one way you can do this as a good mathematician is to remember that 6 is the same thing as 3 factorial, which is the same thing as 7 minus R factorial. And as I explained in the last example, if we have 3 factorial being equal to 7 minus R factorial, that means we are saying essentially that 3 is equals to 7 minus R. This means our R will be equals to 7 minus 3, which will be equals to 4. So R obviously is equals to 4. Is it making sense now? Are you guys understanding how tricky some of these things could be and how easy it is to solve them? So this is how you deal with permutation and combination. You guys are making real progress. I really salute your progress so far. You have been doing really great. Your responses have been very positive, and I really wish you the very best. So let's see this other question we have here. We have this question right here. So can you make an attempt to this? This question right here, this question number 3 on equation involving permutation. So I love the way we are moving in today's class. We are covering quite a number of subjects. I love it. So let's keep it up. Um, we should be able to exhaust ourselves on permutation tonight. So can we have the answer to the question? So we have three open brackets n permutation 2 plus 24 being equals to 2n permutation 2. Okay, we have answers coming in. Somebody said 8, somebody said 8, somebody said 2, somebody said 8. Okay, do we have any more answers? So you're going to learn something very important under permutation in this particular question. So please make sure you are glued on your screen, because one of the things we're going to be doing here is going to really help you in being able to tackle questions involving permutation. I want you to understand that it's true we are dealing more with permutation in today's class, but you will be having the same thing, equation involving combination. So an equation involving combination sometimes could be much more complex because of the nature of combination. So you have to understand some certain skill set that you will need. Is there anybody making any other attempt on this question? Can we move on with solving it? All right, now, you know the first thing we have to do. We have to use our initial n permutation r equals to n factorial over n minus r factorial. We have to use this to deal with this and deal with this. That's very important. We have to deal with those two things. So let's try and deal with that first. So we have 3 into bracket. That'll be n factorial over n minus 2 factorial. All right, plus 24 equals to this 2n, don't forget, is together. That's 2n factorial over 2n minus 2 factorial. This is the very first step, which I believe everybody should be able to do. All right. Now, the next thing we want to do now, please pay attention. I'm sure you understand the idea around permutation. Look at something, guys. Let me do something for you here. If I said 9 factorial over 4 factorial, I'm sure you guys agreed with me that I could write it as 9 times 8 times 7 times 6 times 5. Or let me just, you know what, because of space, let me use 7 factorial. So I can have 7 times 6 times 5 times 4 factorial, and I left it over 4 factorial. I'm sure you guys agree with me that this was okay to do, because I was trying to, and look at what was happening here. This was 6 was 7 minus 1, 5 was 7 minus 2, 4 was 7 minus 3. I'm sure you can see what was going on. Now we're going to use this same concept now to tackle this question. Look at what I'm going to do. Please pay attention. We're going to open our bracket. Now I'm going to write n factorial. Look at it. But I don't want to write n factorial in short because I want to use that concept. So what I want to do is I want to write n times. So I'm going to act like I'm doing what is going on there. Look at. I want to act like, you know, look at what we did when we were trying to solve this. I said 7 factorial was 7 times 7 minus 1 times 7 minus 2 times 7 minus 3. When I got to where I was seeing 7 minus 3 happening at the denominator, I stopped it there. That's a concept you must always learn. So when I see something like this, I can see n factorial. N factorial is the same thing as n times. Now, I can go on to have the next one as n minus 1. Now, I could have stopped it at n minus 1 factorial, but that would not have given me, because don't forget, that was the first thing. The first thing you do after you write the n is to subtract 1. As you wrote 7, you subtracted 1 in the next instance, then you subtracted 2, subtracted 3, on and on and on until you got to a place where you met the denominator alike. Now, look at this, was the denominator here, n minus 2 factorial. If I stop here, I will not have done something that is very useful. So I can still go on, which is permitted. I had n times n minus 1. I can go on to have n minus 2 and stop it here. The reason why I'm stopping it here now is because I can see my denominator conforms to what I'm seeing there. So it makes so much sense. So I want to go on now to leave it as that, because obviously the fact that I have it like this means I can easily cancel these two things. You see exactly what I did using my understanding of permutation. Now, in this other phase now, look at what I can do also. The denominator has 2n minus 2 factorial, right? So look at what I'm going to do now. I'm going to write 2n factorial will be 2n multiplied by 2n minus 1. If I stop here, I will not be doing something very useful, because obviously 2n minus 1 is not what we have beneath. So I need to take it a bit further and try to do the next one, which is possible 2n minus 2. Then I will stop it here. I'm stopping it here not for any other reason other than I can see my denominator appearing here. So it makes sense to me. I can leave it there. Then you see, obviously, I can cancel these two. Now, if you see what's going on there, now I have 3 into bracket n times n minus 1, then plus 24. You can see how that was. And this is also 2n times 2n minus 1. Right? You can see what's going on there now. Good. So the next thing to do, obviously, is that you want to try and open up all these your brackets, because these brackets are quite, you want to open the one within. And obviously, to open this one within, you'll be having n squared minus n plus 24. You want to open this one also. This will be equals to 4n squared minus 2n. All right. Now, you now want to open this bigger bracket. So you'll be having 3n squared minus 3n plus, what is 24 times 3? 24 times 3 will give you a total of 72. Equals to 4n squared minus, this is 2n, not 3n. You can see how nice this is. This is how you tackle equation involving permutation. Gently, using all your understanding of algebra and everything. So you know what to do next now, because this obviously looks like a quadratic expression already. So I want to move all of these expressions. I want to move all of them to one side. So you know what to do. I want to probably shift all this here, and then I'll be having 3n squared, of course, minus 4n squared, minus 3n, then plus 2n, then plus 72 equals to 0, following every mathematical principle I know. So this will obviously be minus n squared minus n plus 72 equals to 0. All right. So obviously, you know that I can easily go on to multiply through by minus, and I'll be having n squared plus n minus 72 equals to 0. Right? Now, look at this. This is n squared plus n minus 72. You can now go on to use your principle of factorization or any other method of solving quadratic expression. Looking at what I have here, I think I can see clearly I can have like two different factors here, and that will be n squared plus or minus 8n plus 9n minus 72 equals to 0. So this will be n into bracket n minus 8 plus 9 into n minus 8 equals to 0. That will be n minus 8 and n plus 9 equals to 0. Of course, this will be n equals to 8 or minus 9. Now, n equals to 8 or minus 9 is my final answer. Now, it is clearly impossible for you to have your n being a minus 9 because you cannot have minus 9 permutation 2. That is not feasible. You cannot have minus 9. You don't have situations like this. Minus 9 object. It's not right. All right. So the answer will obviously be n equals to 8. Does it really make sense? You guys really get the point? Is everybody flowing in the class? Or do we have people, is there anyone that has any place where you felt a bit confused? I feel this is quite very much clear, and I believe everyone should be able to really flow with it. All right, now we have important questions. These questions now, let me say one thing. If you're able to get all of these questions without missing anyone, then that means you have truly understood permutation. If you are in this class and you get every question I'm going to throw at you right now without missing one, then that means you have truly mastered permutation. This is the test of your understanding on permutation. All right, are you ready to go? You're ready to go. Give me your favorite emoji or or sticker or whatever. Let me hear you. Are you ready to go? You're ready. If you know you're ready, let me have it. I want to start shooting the questions. Again, don't forget. And again, let's say this. Let's make this deal, right? Let's make this deal. You don't retract your question. You don't retract your answer from the chat box. You drop your answer immediately. You don't wait for anybody to drop his own answer before. Just drop your answer as you get it. If you can make me that promise, then I will be looking forward to seeing somebody that will get every of the answer without missing anyone. All right. So make that promise to yourself that you will not retract your answer and you will not wait for anybody before you drop your answer. That's the way we're going to know that you are truly, 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 truly ready. All right. So it's time. Good. This is the first question. Question number 1. How many four letters arrangements? By the way, you have just 2 minutes to solve the question. How many four letters arrangements of the word family are there if it must start with a hem? 2 minutes. Drop your answer in the chat box. 2 minutes maximum. Drop your answer in the chat box. How many four letters arrangements of the word family are there if it must start with a hem? How many four letters arrangements of the word family are there if it must start with a hem? Drop your answer in the chat box. 2 minutes. You have about 90 seconds to go. You have about 60 seconds to go. Now you have 40 seconds to go. You are not, no retracting of answer, no checking anybody's answer, just drop your answers. Now you have 20 seconds to go. 10 seconds to go. 5 seconds to go. and that's it. All right. Now, among every answers I can see here, if you wrote your answer as 60, you are correct. Good. That's the only, and those are the people that got the answer correctly. Now let's solve together. How many four letters arrangement of the word family are there if it must start with a M? How many four letters? Look at the arrangement we're interested in is just four. How many four letters are there if it must start with a M? It must start with a M. That means out of this word family, look at the word family. We are saying already now that M must be the starting point. So this first place is filled up already. So you are not trying to fill the first place. The first place is filled already. It must start with a M. That it must start with a M already tells you already that even though it's a four-letter word, M is filled up. First letter is filled up. So you're only having three spaces left to fill. And how many alphabets are left with family that you have not used? Of course, you have not used 5 out of them, and you are trying to arrange. You don't need, or you're not trying to arrange the whole 5 because you only have 3 spots, right? So you are having 5 letters left, and you are interested in arranging just 3. So your answer will be 5 permutation 3, which will be 5 factorial over 3 factorial, which is 5 times 4 times 3 factorial over 3 factorial. Are you sure this is correct? What's 5 permutation 3? Oh, sorry, 5 minus 3, 2 factorial. That will be 20 times 3, that's 60. Does it make sense to you guys? Do you see where you needed to have done better? Number one, it's fixed. That's the first thing. Understand that how many four letters arrangement of the word family are there if it must start with a M? Even though it's 4 letters, one is fixed, you have only 3 left. Among those 3, you don't have, of course, you cannot use M again. So you only have 1, 2, 3, 4, 5. You only have 5 letters you can pick from. So if you wanted to use the second method I explained to you, this first letter, when you have 5 left, can be arranged in 5 ways. This one can be arranged after you have used 1 here, you'll be having 4 left here. And then after you have used 1 here, you'll be having, that will be 5 times 4 times 3. This is another way of doing it if you want, if you prefer this. If it's not fixed, it's a different point entirely. If it's not fixed, it's a different point entirely. So you follow what the question says, right? So good. So now let's go on now. Of course, if you miss that, you still have opportunities to prove yourself strong. Make sure you don't miss any other one. We have quite a number of questions here to solve. Look at this question quickly. Okay, I'm going to ask you this one first before asking the one I wanted to ask first. I'm sure you guys, please, can you indicate if you truly understand what I just said? You understood this last question, you gained from it. Okay, that's good. In how many ways can a 7-letter of the word I be maths be arranged if the first letter must be a vowel? 2 minutes, 2 minutes, 2 minutes. You have just 2 minutes. And you have 100 seconds more. 100 seconds more. 90 seconds. 90 seconds. In how many ways can the 7 letters of the word IB mat be arranged if the first letter must be a vowel? You have 60 seconds more. You have 60 seconds more. You have 60 seconds more. 60 seconds more. Okay, now 40 seconds. Now 40 seconds. Now 40 seconds. Now 40 seconds. All right, 30 seconds. 30 seconds. Once the time is out, that's all. Okay, 15 seconds more. You have 15 seconds more, 10 seconds more, and yeah, we're done. All right, if you wrote your answer as 1440, you are absolutely correct. Good. Let's solve this together, guys. In how many ways can the 7 letter of the word IB mat be arranged? Now, the condition was the first letter must be a vowel. Look at the word IB mat. IB mat. How many vowels do we have there? We have this. We have this. These are 2 vowels we have there. Good. So that means the first letter must be a vowel. They say in how many different ways can you arrange the 7 letters? That means in this case, now I want to arrange all the 7. Obviously, you can see we have 7 letters. 1, 2, 3, 4, 5, 6, 7. We have 7 letters. Now, but the condition here is that all your arrangement must start with a vowel. So it can either start with A or it starts with I, but it must start with a vowel. Okay, so let's try to solve this easily. So we have 1, 2, 3, 4, 5, 6, 7. Let's make it this way. So we have 7 something right there. This first one has a condition. It must be a vowel. So obviously, it can start in 2 factorial ways. 2 factorial ways because you can put it as, you know, we have 2 objects that can fill this place. And the way you can arrange 2 objects here is actually 2 arranging 2. So you can put I here or you can put A here. Don't forget, please, that if you put I here, you can have A among these other 6. So you don't, the fact that you have used I here doesn't mean you cannot use A here. So if you fix I here, A can still be anywhere here. So obviously, you want to say the number of, once you have fixed this first one, you are left with only 6 objects left. And these 6 objects, you can permutate them in different ways. So the way you can arrange 6 objects after you have fixed this one. So let's say you fixed I now. BMATHS is the other object now. You can arrange this BMATH. Let's say you fixed I. You can arrange BMATHS in 6 factorial ways. Now, it also happens that if you decided to put A here, you can arrange IBMTHS. That means the other 6 objects in 6 factorial ways also. So normally, if you were only using I and you didn't have the opportunity of, let's say they said it must start with I. If it must start with I, of course, your answer will just be 6 factorial ways because you will not be, but because you can still make another possibility of putting A as the beginning here, that's why you have to multiply this 6 factorial with 2, which is 2 factorial ways, because A can also come here, I can also come here. So the answer will be 2 factorial times 6 factorial. And that will be, if you do that carefully, you get a total and a final answer of 1440. All right. Is anybody right here in this class that has gotten the first question, has gotten the second question? I can assure you that very soon, if you are there, you would. You may, I wouldn't say you will, because it's possible some of you are very great in this. But again, I said already, if you are able to conquer every of the questions I'm going to ask you to the end of this class, then that means you are already very solid. Of course, if you don't get it, one thing that will just happen is you will get better, because the fact that you follow through with the solution will make you get better. And then in the testing of tomorrow, you will be able, you have the opportunity to improve. All right. Now, look at this question. Let me see how you solve it. We have 6 friends. They go to a movie. These 6 friends, they are going to a movie. This is the name of the 6 friends. They are not names that many of you can relate to. The first one is Hal. The second one is Bob. The third one is Carl. The fourth one is Dan. The fifth one is Ed. And the sixth one is Frank. If you can notice, you can see they all have an initial summing up to A, B, C, D, E, F. All right. So how many ways can they sit if this is it now? Let's solve the first one first and let me get your answer. If Bob and Frank want to sit together. Your time has started. Just 120 seconds. 6 friends go to a movie. These are their names being Hal, Bob, Carl, Dan, Ed, and Frank. How many ways can they sit if Bob and Frank want to sit together? Oh, somebody retracted the message. Adebola retracted the message. You wrote 13 now, okay? All right. Bob and Frank want to sit together. Can I get answer? Adebola has retracted again. Adebola the retractor. Okay. So Bob and Frank wants to sit together. Can I get solutions quickly? Bob and Frank, they said we must sit together. We are giving my solutions. We have 100 seconds more. Okay, now 90 seconds. Now 80 seconds. Now 60 seconds. Now you have 40 seconds. Now 30 seconds. Okay. 30 seconds to go. Where is Akonde praise? Now 15 seconds. Now you have 10 seconds. Yes, they must sit together. Bob and Frank want to sit together. Okay. 5 seconds. And you're running out of time. 5 seconds, you're running out of time. All right. Done. Now let's move on. Now, if you got your answer as 240, you are absolutely correct. So we give them a round of applause. Can we? Okay, anyway, so let's go on to try and solve this. We did something similar to this yesterday, and I told you already how to solve things like this. 6 friends go to a movie. A, B, C, D, E, F is their name. How many ways can they sit if Bob and Frank said C, both of us. So we have the friends as A, B, C, D, E, F. But Bob and Frank said we must sit together. And we are asked to now solve for the number of ways they can sit if this condition must be fulfilled. Now, these two, they are together. So we're left with A, C, D, E. So now, A, C, D, E, is it A, C, D, E? Okay, A, C, D, E, yeah. A, C, D, E is the friends that, of course, they don't have to sit together. These ones can sit anyhow they want to sit. But one way I taught you to solve questions where you said something must be together is that you will take this one. Normally, if you were not having this condition, you would have seen this as 6 objects. But because of this condition that says they must sit together, you will take this BF as one object. So this will be the second object, third, fourth, fifth, because this will be taken as one object. That means anywhere this B go, F must follow it. So the meaning of that is that you can have A, D, E and put this object here. But if you put this object here, it is an object that carries BF. So you see that this way they will always sit together. You can decide that, okay, you want to make it A, D, then you put the object here, E. This one object we are seeing as one, of course, it carries BF. You see, that way they are always sitting together. So that's the way you deal with things like this. That's the way you deal with things like this to ensure that they are always sitting together. All right. Now, if you look at this now, generally to arrange this in different ways will be 5 factorial, because you can have these different arrangements, moving them around. We are having just 5 objects now, so we are obviously going to be saying 5 factorial. That means we have 5 objects. We are arranging 5 of them. That's 5 factorial. Now, but this cannot be your final answer. The reason is because even though we have BF, right, we can decide that we want to say FB also. So this way, we have this happening also in 2 ways, in 2 factorial ways. So the final answer will be, considering that we could also have BF being FB. So that BF being FB can have, of course, that's 2 objects. 2 objects can be rearranged in 2 factorial ways. 2 objects arranging 2. That's how we have 2 factorial. So 2 objects arranging 2, we have 2 factorial ways. So the general answer now will be these 2 factorial ways times 5 factorial. So if you do this, you should get an answer of 240. Right? Good. Now, that's nice to hear that many of you got this. Now, let me see. We still on this same question. We have another question on it. And the question is now, look at this question now. Now, Al, Bob, you have just 2 minutes again. Al, Bob, and Carl should not sit together. Look at the question now. Al, Bob, and Carl should not sit together. 2 minutes. 2 minutes. Al, Bob, and Carl should not sit together. Al, Bob, and Carl should not sit together. 2 minutes. 110 seconds left. 100 seconds left. Ninety seconds. 90 seconds. 80 seconds. 70 seconds. 60 seconds. You have just 1 minute left. Where is praise? I'm not hearing from praise. Where is praise? Okay. You have 30 seconds left. Always give me the final answer, by the way. Don't leave it in factorial. And you have 15 seconds more. 10 seconds more. 5 seconds more. And that is it. All right. Now, if you wrote 702, do I continue saying? Anyway, that's just on. Oh, somebody wanted to write 726. Somebody wrote 720 once he heard that. Can you imagine? Anyway, if you wrote 576 as your answer, you are absolutely correct. All right. All right. How do we get this answer? Somebody wrote 5,776. Atom. Ba? Okay. Atom wrote 5,776. Let's try and solve this question very quickly because now, is there anybody here that has gotten every why are people retracting? We had an agreement. You guys should not retract your answers. Okay, so is there anybody here that has gotten all the questions from scratch since when we started this? You've been getting everything non-stop. Is anybody? Let me see. Is anybody? You've gotten all the answers without missing anyone. All right, let's look. Okay, now let's try and see this. Look at the question. A, B, and C should not sit together. A, B, and C should not sit together. What's going to happen here? Of course, you have to go and find when they sit together. How do you, if A, B, and C should not sit together, that means you are saying you must not see A, B, C being close to each other. D, E, F. Okay. Now, one thing you can do, honestly, here is to quickly go and solve for them sitting together. I think I taught you that yesterday. So go and solve for when A, B, C should sit together. So if A, B, C should sit together, that means you're going to take A, B, C as one object, as I explained earlier. So now, normally, without this condition of them sitting together, you would have said this were 6 objects. But because they must sit together now, don't forget, I understand the question was should not sit together. But I want to go and solve for when they must sit together. So if they must sit together, that means I'm going to take A, B, C as one object. So that means instead of having 6 objects now, I'll be having 1, 2, 3, 4. So I'm having 4 objects now. And to arrange 4 objects, that will be 4 arranging 4 objects. That will be 4 factorial. All right? Good. Now, 4 factorial is the arrangement that will give you them sitting together. Is that the final answer? Absolutely not. You say why? ABC can happen in how many ways? You cannot just have, it's possible for you to have BAC because them sitting together is what we are trying to solve, not that A must be the first, B must be the second, and C must be the third. We just said they must sit together. So they are still sitting together if B was the first, A was the second, and C was the third. They are still sitting together. So obviously, after arranging all these 4 objects, you understand why I said 4 objects, because we are taking these 3 of them as one object. You also need to consider that A, B, C can happen in how many ways? Of course, this is 3 objects inside here. We can arrange these 3 objects in 3 permutation, 3 ways, which is 3 factorial ways. So it's possible you have A, B, C. It's possible you have B, A, C. It's possible you have C, A, B. It's possible you have A, C, B. You know, you can see all these possibilities all still sitting together. So all these possibilities, if you exhaust all of them, will be 3 factorial ways, which is 6 ways. So this is 6 ways. So if you want to get the final answer of them sitting together, you would say 6, of course, 3 factorial times 4 factorial. And that will be 6 times what? 24. 6 times 24 will give you a final answer of what? What is 6 times 24? I hope I have not done a mistake somewhere. Okay, that's 144. So 144 is the answer for them being mandated to sit together. Now let's come back to our original question. Our original question said they should not sit together. They should not sit together. So the way to get this, they should not sit together, will be you going on to now solve without any condition. So let's even throw away the condition. That means we don't care if they are sitting together or not. They can sit together, they cannot sit together. We just want to solve everything. We don't want to follow any condition. If we just have this A, B, C, D, E, F guys, people staying together, what can we do? If we want to just permutate them, when I say permutate, you understand what I mean. We want to just arrange them without any condition. That means A, B, C, D, E, F. There are obviously 6 objects. So the way to arrange 6 objects will be 6 arranging 6, which is 6 factorial. And what is 6 factorial? 6 factorial is obviously 720. So this is what you will do. This is your answer if you have no condition. This is the condition. This is when there are no conditions. But now that there is a condition for them to sit together, this is for them to sit together. All right. But what we had to find was them not to sit together. So for you to find this not to sit together, you will just go and subtract all when they are sitting together from without condition. So that will be 720 minus 144. And that will give you a total of 576. All right. So you can see how nice and simple permutation is getting. Now, this is the question that I'm almost very sure 70% will probably not get this question. So you can prove me wrong. Of course, make sure that you are not trying to make sure you are not trying to use any AI or whatever. Of course, if you're doing that, of course, that's not going to be credible. All right, this is the question. Let me see what you're going to do with this. How many 4-digit integers how many 4-digit integers greater than 3,000? Okay, somebody said I'm making it complex. Am I making it complex? No, I'm just exposing you to much more technical questions. And that's the way it should be. I'm supposed to carry you bit by bit into higher level of technicality. I don't want to start teaching. If I started teaching with some of these questions, many of you would not feel encouraged to even attempt permutation. But I'm sure you guys will get it. It's not about the difficulty, by the way. All right. It's not like it's difficult. Once I'm done solving it, you will see how simple it is. So it's not like probably it's difficult. It's more like just technical. Technical is different from being difficult. I hope you know that. Technical literally just means it's possible for them to ask you 2 plus 2, but they're going to give you in a different way that if you're not exposed enough, you probably don't know they were asking you to solve 2 plus 2. So that's what's happening here. So I'm just increasing the technical levels of question so that you guys can, because it's very important that you solve more technical questions, not difficult questions. None of these questions are difficult. They are just technical. And it's only technical because of the way they are worded. All right? So look at it, guys. How many 4-digit integers greater than 3,000 can be formed using 1357? That's the three different integers you can use if no digit is repeated. So let me read it one more time before I start counting the time. How many 4-digit integers? Ha, guys are on fire. I see them just throwing answers without me even. How many 4-digit integers greater than 3,000 can be formed using 1357 if no digit is repeated? One 10 seconds more. 100 seconds more. I like the way I'm saying. I love your courage, by the way. See the way you guys are throwing answers already, even without us doing anything. That's so nice. Question why I think say they difficult. I don't see the answer for chat box already. Wow, these guys are on fire. Oh. Wow, that's so nice. Eh, okay. Wait, oh, did I say 70% we're not going to get this question? Probably I meant to say 70% was going to get this question. Wow, you guys are really, and that's so nice to see. Wow, that means you guys have been flowing very well in this class. I can say I'm proud of you guys then. I'm probably proud of myself for teaching you well. That's nice. I thought I was going to scare you. You guys are throwing answers like I wrote I wrote nothing on the board. Oh, that's nice. I've seen the answers already. Oh. Uh yeah. I don't know how you solved this, but I've seen the answers already. You know, won't I go and change the question I set for your test for tomorrow now? Because the way you guys are answering this question, you just see that question will be it's not too simple for you guys. So by the way, I'm not going to do that because your questions are ready already for tomorrow's test. By 9 a.m. you'll be having it. So, but I'm not going to do that. But I still have more questions. Let me assure you guys. I still have more questions. Looks like would you guys like to see me drill you guys on permutation? Looks like you guys are getting you're getting very confident. I'm sure somebody will say bring it on. Wow, no worms. We're going to have more. Don't worry. This is I'm really impressed. I must assure you, I'm really impressed. This is nice. This is nice. Okay. Now look at it. For those of you that don't, the answer is actually 18. By the way, if you wrote 18 as your answer, you are correct. So the answer is 18, and that's so impressive. Look at it. Look at the question you were asked. You were told to give the number of 4-digit integers. Now look at the condition: greater than 3,000. All right, greater than 3,000. Greater than 3,000. I'm sure you know greater than 3,000 means you can have three. Look at it. You are forming using these four integers. So if it has to be greater than 3,000, we know already that 1 cannot start this first one. The first digit cannot start with 1. Because if the first digit start with 1, anything 1, even if you put 7 next, 5, 3, which is probably going to be the greatest integer you can form using 1 as the beginning, this is still not yet up to 3,000, right? It's not yet up to 3,000. So now greater than 3,000, greater than 3,000 must have at least 3 as the first integer. So we can have 3 here. We can have, this is not permitted, this one is not permitted. We can have 3 as the first one. We can have 5 as the first one. We can have 7 as the first one. This will all give me integer values greater than 3,000. Do you get it? Right? Good. So this is the only thing that will not be accepted as the first value. So we already understand that that means the first digit. That means I'm sure you know this is the, how many of you did 100 tens and units in primary school? If you did it, prove me wrong. Prove me right that you did it. Tell me, what do we call this? What digit would we call this one? Is this unit? Is this tens? Is this 100? Oh yeah, this one I'm touching here. Prove me that you went to primary school. Okay. Yeah, somebody wrote unit. You know, I know people will not go primary school did this chat. I know. Okay. So I know some people did not go to primary school. All right. So the thousand digits can happen in 1, 2, 3 ways. You can see it. Good. Now look at this other condition. If no digit is repeated, that means after you have written 3 here, you can never write 3 in any other place. So this second, the 100 digit, if I've written 3 here, don't forget this one is not possible. If I have written 3 here, I cannot write, I have, of course, many options I can put here. I can put 1 here, I can put 5 here, or I can put 7 here, but I can never put 3 here. Same thing goes for if it was a 5 scenario. I can put 1 here, I can put 3 here, I can put 7 here, I cannot put 5 here because it must not be repeated. Same thing goes for this, if your 7 was the beginning, I can put 1, I can put 3, I can put 5, but I cannot put 7 here. So that means the 100 digits can happen in also 3 ways because of that fact that said there must not be repetition. If they didn't tell me that there must not be repetition, if they didn't tell me there must not be repetition, this place would have been able to happen in 4 ways because I would have been able to repeat the same thing there. But because they said there must not be repetition, that means these are the scenarios that can happen. That means each of the 100 something will always happen in just 3 ways. Now, what about the tens? The tens digits. How many ways can that happen? Of course, we have, if we have put, let's say we put 1 here now. Don't forget we cannot put 3 in any other place here. We'll be left, if we put 1, or if we put 1, we'll be left with only the possibility of putting 5 and 7 here. If we put 5 here, we'll be only left with the possibility of putting 1 and 7 here. If we put 7 here, that means we'll be left with the possibility of only putting 1 and 5 here. So that means this tens unit will be able to happen in 2 ways. 2 ways. And then the unit, once we have added, say, if let's say after we fixed in 1 year, let's say we decided to put 5 here, this one will be able to happen, the units digits will be able to happen in 1 way. So the total will be 3 times 3 times 2 times 1, and that will make a total of 18 different ways. How many of you were able to follow what I just did right now? You really understand what we just did. You understood the whole concept. Can I get your can I can I get your response? I really understood. Yeah, I understand. Obviously, I'm sure you understand that different methods can work as long as you do the right thing. Yeah, as long as you're doing the right thing, it's yeah, yeah, it's okay if you used a different method. So who has gotten so far all the questions that I've given? If you know sincerely, you've gotten all the questions. You've gotten all the questions that I've given you without missing anyone. Somebody said, "Oh yeah, tell me." Anybody? Nobody. Wait, nobody has gotten. Ah, is that not sad? I thought somebody should have gotten. You got everything. Oh, okay. Somebody said he missed one. This is three, by the way. Permutation three is equals to 4 times n plus 1 permutation 3. You have to find n in somebody only got one. You have to find n. What is n? Oh yeah, oh yeah, oh yeah. 30 seconds. Oh, sorry. Uh you have just 2 minutes and you have 100 seconds left. N is what? Looks like somebody is waiting for somebody's answer. So n is what? And we don't have an answer yet. Oh yeah. Double up, guys. We don't have an answer yet. You have to find n, not n factorial, guys. N. Find n. That was supposed to be question mark. Somebody said 14. Okay, Priest was the first person that wrote 14. Atom went on to write 14 also. Any other person with a different answer? Somebody said 14. I will just write 14. What if no be 14? Let me get all the answers. What do you get as the answer here? Are you having a difficult time solving this? So this obviously will be that'll be 5 times this. That'll be 5 times n minus 1, n minus 2, being equals to 4 times, this is n plus 1. So this obviously will be n plus 1 factorial over n plus 1 minus 3 factorial. This obviously will be n plus 1 factorial over n minus 2 factorial. If you go on to solve this, obviously you would have, this would be n plus 1, n plus 1 minus 1, that will be n. Then n plus 1 minus 2, that will be n minus 1. Then n plus 1 minus 3, that will be n minus 2 factorial. So you leave it at that, n minus 2 factorial. This will cancel this, you are left with just this. So that means what you are having here will be n plus 1 and n minus 1. 4 is multiplying all this, right? So if 4 is multiplying all this, of course, looking at all this, I don't need to even, I can go on to divide both sides by n minus 1, because I know that would, and also n. So n will cancel n minus 1, the same thing will happen here. N and n minus 1, they will both have an effect here. So we'll be left with 5 into bracket n minus 2 equals to 4 into bracket n plus 1. That will be 5n minus 10 equals to 4n plus 4. That will be 5n minus 4n equals to 14. That will be n equals to 14. Priest was the first person that gave us the answer. Priest, drop your phone number. Your phone number, oh, I know say me you drop your account number. Now your phone number I say me you drop. You will say I do giveaway, Abi. I won't do giveaway for Priest. If Priest dey ready, if not, the next person go carry am. So Atom was the next person. I don't know if Atom got teacher or he just photocopied Priest stone. Where is visibly Priest or something? Oh yeah, drop your phone number. Let's have it. Eh? But while you're dropping your phone number, you guys should take this question. Let me see what you do with this question. somebody said he dropped. Okay, wait. While we are at this, we still have about 2 questions to solve quickly. You guys are so hilarious. Who they drop money points for you? Why you don't drop your BVN? The only money points they drop. The person saying also is OP. Okay, while I'm waiting for Priest, how many words can be formed by rearranging the letters of the word? Take this question down quickly. I know say everybody go on quickly drop this answer like in 3 seconds. How many words can be formed by rearranging the letters of the word accent such that A and T occupy the first and last position respectively? This is the simplest question of all. I know the answer for don't day that place already. Oh my. Okay. So, how many words can be formed by rearranging the letters of the word accent such that A and T occupy the same, the first and last position? Answers don't too plenty yourself. Okay. Okay, but I say priest talk say you no one drop his phone number back because I don't see any phone number of priest though. Why am I seeing different answers in this question? I thought this was the simplest of all questions. All right. I want to see who gets this answer quickly. I didn't wait, by the way, let me do this one, then I will do the previous one. In how many different ways can 6 different rings be worn on 4 fingers of one hand? In how many different ways can 6 rings in how many different ways can 6 rings be worn on 4 fingers of one hand? In how many different ways can 6 different rings be worn on 4 finger of one hand? In how many different ways can 6 different rings, 60 seconds more? In how many different ways can 6 different rings be worn on 4 finger of one hand? $30 more, 20 seconds more, 15 seconds more, and 5 seconds more. Right, so we are done. Now, this guy or this person called Atom first wrote 4096. I watched him as he retracted it. So, Atom, can you tell us why you brought your answer back? Lucky you actually got the answer, and you'll be the second person collecting the giveaway. So 4096 is the answer. Let's talk about it quickly. All right. All right. So let's go. You have 6 different rings. You have 4 hands. They say how many ways can those 6 different rings be worn on 4 fingers? That means ring 1 now. You have one, let's say this is ring 1. This is ring 2, ring 3, ring 4, ring 5, ring 6. Look at it. Oh, these are different rings. Don't take this as numbers as their values. Oh, this is ring 1. Maybe I should write R1, R2. Maybe that would help for better understanding. So let's say you have all these rings. They say how many different ways can 6 rings be worn on 4 fingers? How many different ways can 6 rings be worn on 4 fingers? So look at it. This ring 1, you can wear it in 4 ways on 4 of the fingers. That's quite simple. More like you can fix it on this or this or this or this. That's just simple. That's 4 different ways that ring can be worn. Ring 1, because they say 6 different rings. So ring 1 can be worn on the 4 fingers, can be worn on 4 fingers of one hand in 4 ways. Ring 2 also, 4 ways also. So that will be 4 times 4 times 4 times 4 times 4 times 4. And that will give us 4096. Does it make sense to you guys? It's that simple. So now the previous question we solved, accent. We said, how many ways can you arrange this word accent such that A and T occupy the first and last position? I saw different answers, and the 4 different answers I saw different answers rather, and I was quite surprised because if we have 1, 2, 3, 4, 5, 6, we have 6 objects, and we're already fixing 2 of them. We said A and T occupy first and last. This is fixed. This is fixed. That means we cannot make any arrangement. Don't forget, they didn't tell us that A and T can be swapped. You cannot bring T as A, and you cannot bring A as T. If you get that point, you have to make it A as the first, T as the last. So obviously these are the only other things you want to arrange. That's S, C, E, N, which is 4 different objects. So the ways you can make this arrangement will obviously just be 4 factorial, which is 4 times 3 times 2 times 1. This is 12 times 2. So the answer is 24 ways. All right. So that's just it. Somebody said I should explain the ring question again. In how many ways can 6 different rings? 6 different rings. 6 different rings. This is, let's say this is ring 1, ring 2, ring 3, 4, 5, 6. Can it be worn on 4 fingers? You have 4 fingers. Now, how many different ways can these 6 different rings? You can wear ring 1 here. You can wear ring 1 here also. They didn't restrict anything. All right. So ring 1 can be worn in 4 ways. That's finger 1, finger 2, finger 3, and finger 4. Same thing as ring 2. It can also happen because there's no restriction. There's no condition that was set. You can wear ring 2 in 4 different ways also. Same thing as ring 3, same thing as ring 4, 5, and 6. So obviously we have just 4 times 4 times 4, in short 4 raised to power 6, which will give us 4096 different ways. So guys, I have another meeting to run into. It's been a very terrific time today. I loved your participation. You guys did so well. I love that you guys are not afraid to try. And I'm sure you have gained so much from today's meeting. It's quite very nice. And by the way, where is Priest and Atom? Where is Priest and Atom? Let me get your number quickly because I'm going to be out of here any moment from now. Can I get your can I get your I didn't say your account number. Okay. That's okay. I think I can see it right there. So if you like, maybe not be your account number, maybe you won't make mistake. Oh, now you sabi. Where's the other person? Okay. So, okay, where's the other person? I'm jumping out of this place. Thank you guys really for joining. It's been a very pleasing moment, and tomorrow we'll be jumping into combination. We'll jump into combination tomorrow. So, guys, by the way, by 9 a.m., you have to run into your test zone also, where you would have lots of great questions on permutation. It's the same format. By 9 a.m., you'll be having it. So make sure you ensure you do the needful, and I'll be watching from. I'll be watching very close by to see how you guys perform. That's a good way of testing all the knowledge you have accumulated for the past three different classes. So guys, it's been a wonderful time. I would see you tomorrow. Ensure you do well to study and ensure you are very much ready for. By the way, where is this guy? Priest, are you still there? Priest, are you there? Tell me if you have seen anything, or so that at least I know that I've not. Priest, are you there? Indicate if you have seen something. Let me know. Okay, good. That's good to hear. Thank you very much. I'll see you tomorrow. Bye bye. Take care of yourself.